In this video, I'm going to show you how you can process a unit to segment epithelium and stroma. So we just trained unit classifiers with different values, and we ended up with what looks to be the best training with data augmentation. So we're going to use this classifier and see what kind of results we can get. So first thing, I'm going to open the running notebook. And so it's organized similarly to the training notebook. So we first have one panel to load all the codes we need and Python packages. And then if I run the next code panel, I again have several parameters. So the first one is the images I want to process, then the classifier I want to use, where I want to store these results. And here we have imaging field. So it has to be the same imaging field that was used for training, the number of classes and number of channels. And we have this box, which is a score. So actually, here we have two possibilities. Either we process the images and we get a score at each pixels for all classes. So for example, here we have background, epithelium, and stroma. So we're going to have a score between 0 and 1 for each of these classes. Or we can use not to check score, and then we'll have only at each pixel we'll have 1 for the class that has the maximum score and 0 for the others. So just to see what kind of results we get, we're going to run the same classifiers but with and without scores. So here I'm going to change. So it's as for training, we can batch process. So I'm going to define it as 2, so I can process twice the unit classifier. So the first one, so input directory is going to be in epithelium stroma, and we have test. So let's have a look. I'm going to select it here. I'm going to look at my folder. So here I'm in unit. If I go to datasets in epithelium stroma, training and validation are the folders we used for training, and in test, these are the images we want to process. Let me open one with Fiji just to show you. It's an image where we have two channels, so DAPI in blue, first channel, and cytokeratin in white. So the same channels we use for training, so that's important. We have the same channels, of course. And before going back to the processing, I'm going to define two folders here for the results. So the first one, I'm going to call it results scores, and that's going to be the scores for each class. And the second one, I'm going to call it results, and this time classes, because it's going to be 1 or 0 depending on the class that gives the maximum score. So I can now go back to my notebook, and so the input classifier is going to be in train classifiers epithelium stroma, and I told you that we're going to use the one with data augmentation. So if you look at, they all start the same, but then we have different values for learning rate, and then that's the one we decided to use, the value 0.0001, and this one is without data augmentation, this one is with 10 data, so 10 data augmentation, 25 epochs. I'm going to select this one, so I click on it and then select. Now as you can see, this is in orange. It's just because when you select a folder it's in green, when you select a file it's in orange, and that's what we want, because here we want to select the file, the classifier we're going to use to process our images. So now output directory, it's going to be in epithelium stroma. The first one, I'm going to define the scores, for example, select it. So that's going to be the score. I'm going to check the score. We have 2 channels, 3 classes, 256, 256. That's the imaging field size we use for training, so we keep the same for processing. And now I'm going to define the same parameters, except, so this is in test, the images we want to process, the same classifier, so the one with data augmentation. This time I'm not going to use the scores, but the classes. So here, classes, this one was scores, so this time I don't check this one, I want the classes. We have 2 channels and everything else is fine, so now I can run my classifiers. Again, we have a bunch of warnings, but it's not a big deal. We have 14 images we want to process, and so the first one takes a little bit more time because we need to load the classifier, and then with the same classifier we process all the images. And as you can see, it's pretty fast to do this. Or again, large images, 1800, 1400 pixels, so it's pretty efficient. So let's have a look at the results now. So if I go into the scores first, I'm gonna open it. So it gives you this by formats because it's actually 32-bit images and defined with 3 different channels. So here we have scores. So if the first channel corresponds to the background, the second one corresponds to the epithelium, and the third one to the stroma. So if I go there, here you can see the value. So for example, we have a value of 1. If I go to the next channel, value of 0, and finally a value of almost 0 for the third channel. And I'm in the probably the background, so it seems to make sense here. Clearly pretty well converged to something that looks like background. If I go in this, which probably corresponds to epithelium, I have a low value for stroma, 0.08, 0.92 for the second class, and 0.07 for background. So here we have the scores for each class. If I now open the classes, you see that now we have for each pixel it's only one value. So for example, if I go there, in the background I have value of 0 for first channel, 0 for second, and 1 for the third, which is background. So now it's either 0 or 1, which means we can use this image in Annotator to overlay on top of the image. So let's do that. I'm going to open Annotator here and let's select the first image in test. All right, so that's the one we opened before, and I'm going to load the segmentation we just got. So if I go in the region classes panel here, if I go to load, I'm going to go into result classes because it has to be 0 or 1. I'm going to select the corresponding segmentation, and this is what we get. So overall, if we just look at the cytokeratin, for example, so you can remove the overlaid segmentation by just unchecking region, for example. So here we see that where the cytokeratin is, and if we look at the red region, it pretty much overlaps with it. So it seems that it's a more or less correct segmentation. Maybe where it's a bit faint. For example, here it's harder to make a decision, but that looks pretty fine. If we look at the nuclei here, so we see that the regions where we don't have nuclei, clearly background is in blue. Everywhere else it's either stroma or epithelium. So it could be a little bit better. For example, here we have some areas that correspond to background, which probably would make sense to have them as stroma, but overall it definitely makes sense, and that looked like a good segmentation. Let's open another image randomly. Let's say this one, for example, the 5th one. So I'm going to go back to test. I'm going to take the 6th one actually. Okay. So you see cytokeratin is not, we have high values, for example, here with something a bit weird here, and very faint regions like in here. So let's see what it gives. So if I go back to result classes and open the corresponding segmentation, again it seems that it did a pretty good job. We have a few regions, again here part of a background. It could be something different, but at the same time, if we look at there's definitely the DAPI, there's definitely no cytokeratin, so it makes decision harder to make, and it looks like overall it does a good job.